Alright everyone, this is the big one. This is where we learn to take SQL queries away from the single table question answering that we've learned to work with so far and learn to make it work off of multiple tables. And I know that doesn't sound like a very big deal at first, but when you realize that this almost infinitely expands what we can do with SQL Server, you'll realize that joins are quite possibly one of the most valuable tools you'll know how to use in any SQL query. So, you'll notice as we've gone over these functions and keywords, I've been presenting this as a boss asking you to pull data from him or pull information for him. You know, I want to know how many items belong to Jerry Martin. I want to know how much money I've made from all my orders, yada yada. Well, we've been able to get away from that, or get away with that, excuse me, because all of these questions could be answered using data that's in an individual table. If I want to know how much money you've made, I can say, well, I'll just total up all the orders. That's how much money we've made. If I want to know how many items belong to Jerry Hansen, I can look at my SKU data, or excuse me, Jerry Martin, and say, oh, well, I run a query on that and I know he has 2 items. So that's good, and that's a start. But now we're going to start discussing other items, such as how much money has Pete Hansen made me? Well, did I say Pete Hansen? Yeah, let's say Jerry Martin. How much money has Jerry Martin made me? Well, I know that Jerry Martin has these 2 items, but I don't know how much money he's made. Well, that's where joins come into play, because we do have in another table, let's see, order item, we have SKU in here. So we could say, oh, well, if Jerry Martin owns these 2 items, I could look for that in my order item and go, wow, Jerry Martin hasn't made me anything. And the boss goes, fire that man. So we can do that by hand as usual. But again, depending on how large the data set is that you're working with, that's not practical. So what we're going to look at is a very special method for pairing data together that belongs in separate tables that we call joins. And there are 2 ways to do this. One of them is using a subquery. And the second one is using the join keyword. And we're going to go over both of these functions, or both of these methods together. The first one we're going to go through is using a subquery. So let's consider the problem. I want to know, well, Jerry Martin's not a good example because it turns out he hasn't sold any items. So let's say I want to know how profitable my water sports department is. So you would get the SKUs that belong to water sports, and then you would look in order items to determine which of those items has been ordered and what the extended price is, yada, yada, yada. So what we can do is the first thing that you do in any join is you need to know where does the data come from. So I've already determined I want to know how profitable my water sports department is. So we're looking at extended price and department in SKU data. So order item and SKU data for this case. Step 2 is what data do you want to get back? So in the case of how profitable is my water sports department, really the only item that I need is the extended price. As long as I craft my query to only pull the water sports stuff, I only just need the extended price. So the data that I need to see comes from order item. And if you want to be more specific, the extended price field. And the way that we note that is with a period, like table dot field. So in this case, order item dot extended price. So I know that it's in this table, and then this is the name of the field. The dot tells me that's the separation. And step 3 is, where do those tables join together? And this is where you have to actually go back to what we had talked about in our first class, where we talked about primary and foreign keys. And if you recall, what I had told you is that a foreign key is a primary key pulled from another table that exists there so that it can create a relationship. So for example, in order item, SKU is a foreign key. It's sourced in SKU data. Like, this is this item, it belongs to Pete Hansen, this is its name. It's in order item so that we know, oh, that order has ordered this item. And it exists to create that relationship. Now, in SQL Server, you're not necessarily given, and I can't speak to SSRS, but you're not necessarily given a graphical means to see that relationship. But an Access database does if you set it up. And we'll be discussing how to do that later. But if you open Cape Cod and then you do database tools and relationships, it will show you where the data relates together. Whoa, graphical bug. Cool. So what we're looking at here specifically is the SKU data and order item relationship. And we see that SKU is here and SKU is here, and that's where those two tables relate. So this is important because we need to know when we join SKU data and order item together, what field are we going to use to do it? And it's usually the field that exists, the field or fields, you can join on more than one field, that exists in both locations. So SKU exists here, SKU exists here. Graphically, you can see that this is the relationship between the two tables. So that's what our join will be on. So where do these tables join together? Order item dot SKU and SKU data dot SKU. Now there is a reason we have to do this, and I'll demonstrate later. So these are the 3 questions that you really need to ask before performing any join. And the answer to step 2 really determines whether you use a subquery or a join to do it. So we'll demonstrate that as we go along. We're going to focus on, in this lesson particularly, as the subquery. The next one we'll go over join, and we'll go over more of the differences there. So a subquery. In this case, I'm pulling data from these 2 tables. This is the data I want back. So let's start with that. We're going to use the same method that we used before, the SQL select from where. And remember, the question that we're trying to answer with this is, how profitable is my water sports department? So I'll leave the relationships window up. Query design, close, and I'll do SQL view. And I'll do select, and depending on what I want it back, order item dot extended price. And you can actually put that in here if you want. Access and SQL Server know how to interpret this table and field format. From in this case it's not necessary. So select, it's always better to be more specific when you're talking about pulling data from multiple tables. Select order item dot extended price from, and that data comes from order item. Now if I run this, it's just going to give me the price that all these items have sold for. Now let's think about another way that we would do this using the N keyword. I could actually go in and look at the SKU data and note down by hand the SKUs that belong to water sports. So I can say, well, water sports has 100, 100, and 100, 200, and 101, 100. I feel like I'm writing binary here. 200. And I can model my query to say, give me the extended price where SKU is in, and hopefully you remember what the N keyword does. 100, 100, 100, 200, 101, 100, 101, 200. And that's just the list that I got from SKU data for the items that belong to water sports. And that'll tell me the items that water sports has sold have sold for this much. But I want to know how profitable it was, so I'll just sum it up. So I'll run it, and I know that water sports has earned me $750. So I could save this query and say, give it water sports profit report. But let's say later on that someone comes in and says, oh, I have a new item for water sports, and it's 101, 300, and it's going to be flippers, for the water sports department. Well, your query is targeting SKUs manually. That means someone would have to go in and edit this query and go, oh, there's a new one, that's right, and go in and fix it. Well, there's a way you can use a query to fill in this particular bit of information. It's called a subquery. So I want you to consider another query before we continue. I'm going to open a new one. And let's think about that problem. How do we get the list of SKUs that belong to water sports? Well, that's actually one of the more simple SQL queries that you guys know how to do. So select SKU from SKU data, where department equals, and I hope you've learned by now, this is a string, so we do what? Single quote, water sports. And this should give me the list of SKUs that belong to this department. It does. Yay. Now, here's the cool part. I can take this query, and instead of the list that I had to write manually, I can put this query in here. It may feel a little mind-bending, but you'll get the hang of it. So what Access does is it detects this subquery and it runs this first. And it takes the list that you get back and substitutes it in for the end clause and then processes the rest of the query. So select SKU from SKU data where department equals water sports. We see that over here. It returns these SKUs. Access then takes this list, substitutes it in. I don't remember what they all are. Substitutes the list in here and then processes the rest of the query. Now here's the important part. I realize that this is probably hurting a little bit, but like I said, you'll get the hang of it. From SKU data, where department, whoops, sports. And I indent it to help kind of graphically show that this is a subquery. It's not necessary. Again, this could all be one line it would run, but indenting it and capitalizing it where it helps to make it a little readable. Now it's important, subqueries are always joined using the end clause, always. And it's important that you join from field to field. So I'm checking where my SKU is in this list of SKUs. There's SKU on both sides, and that's because that's where these two tables relate. If you forget, if you try to say where, well, let's see what else is in order item. If I try to say where order number is in, I'm not going to get any results because I'm trying to join order number to SKU, and that's not where these tables join together. That's not how the relationship exists. Remember that SKU is our foreign key in this table, and that's where it will relate back to another table. And if you don't join it on the appropriate fields, your join won't work as expected. So let's consider if I run this, I'm not going to get anything back. So I'm going to change it back. And anytime that you do an aggregate function in your select clause, it's always going to come back that expression 1000. So it's always best practice to just go back and use the as total revenue. So I know water sports has made me this much. And it doesn't matter if someone goes in later and adds a new water sports item or takes a water sports item away, because every time you run this query, it'll grab every item water sports has and then check to see how much those have been ordered and total it up for me. So that's how joining via subquery works. And you can actually do this on more than one level deep. If you have your textbook, page 77 actually shows an example of a subquery that goes 3 levels deep. But for the most part, we're just going to be working on the one subquery. So subqueries, to fill out the notes, always use the end clause. And here's the big note for a subquery, is that you can only see the data, you can only return the data from the top level table. And here's what I mean by that. I'm returning my totaled extended price from order item, and that's the table I selected from in my top select. If I wanted something from SKU data to show as well, I couldn't do that, not using a subquery. I can't pull something from SKU data here because this top level query is only aware of order item. We'll demonstrate the difference in the next lesson. So take a deep breath, use the examples in the book, read through this section before we continue, because this next part is going to be similar but very, very different, and it's important that you understand the differences in how these two work. So stay tuned. We're in for one more lesson.